This is 9/4. Partial fraction. So if you think about when you add fractions together, you take one part, take one part of the fraction, or one fraction, add it to another fraction, and you come up with a larger fraction or a rational function, right? A larger one. But the partial fraction decomposition is when we take the larger fraction and we break it into the smaller counterparts. And it sounds easy, but it's not as straightforward as you would think, unless you follow a certain strategy. So I'm going to show you that strategy. So let's begin. Here we have 7x minus 23 all over x squared minus 7x plus 10. So the first thing you should do when you're doing this is break the denominator down into, hold on a second. Go ahead and factor your denominator. So we have 7x minus 23 all over, two sets of parentheses, and I want two numbers that multiply together to give you 10, that you can add those numbers together to get -7. So I know that's going to be -5 and -2. So I got x minus 5 and x minus 2. All right, step 1, go ahead and break your denominator down into the factors. All right, and now that's how you should look at it. And now, since there's two factors of the denominators, I know that we're going to talk about some fraction, and it's going to be x minus 5, and another fraction that's going to have x minus 2 as its denominator. I don't know what the numerators are, so I'm going to say the first is A and the second one is B. All right, so we have this, all right, so we got this situation right here. All right, now, if you wanted to get rid of the fractions, right? It's hard to deal with these when you're dealing with the fractions. If you wanted to get rid of the fractions, well, you would need to multiply by the least common denominator. All right, which is the denominator you started with once you factored it. So if I multiply everything by that LCD, least common denominator, then watch what happens. So x minus 5 times x minus 2, x minus 5, x minus 2, x minus 5 times x minus 2. Now, over here, it cancels out, and I'm left with 7x minus 23 is equal to, here the x minus 5 cancels out, and I have a times x minus 2 plus b, the x minus 2 cancels out, and I have x minus 5. So that's the first, or the second, or third step. I don't know how you want to think about it, but that's what we need to be doing next. After we find the least common denominator, we multiply by that least common denominator, which is always just the denominator you started with, right? It's easiest to look at it in factored form. When you do that, now you shouldn't have any more fractions. All right. So now is when things get a little bit different. So the goal here is to find what A and B is, right? We need to solve for A and B. Once I figure out A and B, I have the answer. But it's hard to figure it out when I have three variables here, X, A, and B. All right. So a better way to do this is to say, okay, let's say we want to figure out what A is, right? I want to solve for A. So I need to get rid of the B. I need B to go away. Well, I can say, I can let X equal something. And if I'm strategic about what I let it equal, then it will make my b disappear. So if I think about it, right here I can say, hey, x minus 5 equals 0. If I want to make it equal to 0, b times 0 would make it go away. That means x could equal 5. If I made x equal to 5 and I plugged it 5 in for x, watch what happens. So 7 times 5 minus 23 equals a times 5 minus 2 plus b times 5 minus 5, right? Well, 5 times 5 minus 5 is 0, and b times 0 is 0. So now the b kind of cancels itself. I mean, not cancels out, but it zeroes out. Here I have 5 minus 2, which is 3, so I got 3a is equal to 7 times 5, 35, minus 23 would be 12. Now we can solve for a. Divide both sides by 3. And I got a equals 4. All right. So now I can do this again. Starting with my blue line, right? Starting with this. But I want to solve for b. To solve for b, I just think about, hey, what could I do to make that equal to 0? X minus 2 equals 0. Well, I could let x equal 2. So here I'll say, let x equal 2. All right. So it'll be 7 times 2 minus 23 equals a times 2 minus 2 plus b times 2 minus 5. Well, 7 times 2 is 14. 14 minus 23 would be negative 9 equals 2 minus 2 is 0, right? 0 times a is 0, so we can that zeroes itself out. And then 2 minus 5 would be negative 3, so negative 3b. Then I divide both sides by negative 3. And I got b equals 3. So now I found a and I found b. So now I can come through here and kind of give my final answer, which we said in the beginning. Here, I guess I'll just erase all this, change my color to something new. We said in the beginning this was a, right, something over x minus 5 plus b over x minus 2. Well, now we found a. A is 4. So this was 4 over x minus 5 plus 3 over x minus 2. And that is the separate pieces of the fractions that add together to give you 7x minus 23 all over x squared minus 7x plus 10. All right, let's do another one. All right, so here it's already factored for us. So you kind of saw the overall thing just there. That was like the longest of the problem, or I won't say the longest, but that was the whole lesson. Now let's focus on smaller pieces. So I'm looking for what fractions can I add together to get this, right? So I'm going to say, hey, this is going to be some part over 3x plus some other numerator that I don't know over 2x plus 1, right? I can call this A, and I can call this B. So I set up an equation. Now, for this equation, I don't want any fractions. So I multiply by the least common denominator, which is always the denominator I started with. 3x times 2x plus 1, right? Multiply all my terms by that. 3x times 2x plus 1. 3x times 2x plus 1. Now, this cancels with that, and I have 5 equals my 3x cancel. A times 2x plus 1 plus b times 3x. All right? So now we don't have any more fractions. And we're trying to solve, right? The goal is to solve for a and b. So if we want to solve for a, then we let x equal something that gets rid of b, right? So if you just take this, if I have b times 0, I know it'll go away because b times 0 is 0. So what makes 3x equal to 0? Well, when x equals 0. So I let x equal 0. When I do that, I got 5 equals a times 2 times 0 plus 1 plus b times 3 times 0. Right? That's 5 equals a, because this is 0 plus 1 is 1 times a is a. B just goes away completely. So a equals 5. All right. So now we want to solve for b. So I look at the a. What could I do to make 2x plus 1 equal 0? Well, if I subtract 1 from both sides, then I got 2x equals negative 1. So x equals negative 1/2, right? So I let x equal negative 1/2. Let x equal negative 1/2, and we can solve for b, because that makes a go away. So I get back at this equation, right? That's the kind of one that I'm always going back to. So I got 5 equals a times 2 times negative 1/2 plus 1 plus b times 3 times negative 1/2. All right, well, negative 1/2 times 2 is negative 1. And when I add 1 to that, that's 0, right? That's how we made it. We wanted to make a go away. So now I got 5 equals 3 times 1/2 becomes, or negative 1/2 becomes negative 3/2. Negative 3/2 b. I want to solve for b, so I multiply both sides by 2. And I got 10 equals negative 3b. It canceled, right? I divide both sides by negative 3. And I got negative 10/3 is equal to b. b equals negative 10/3. So now I have my answer. I got a and b. I can say, here we said a over 3x, so a is 5. 5 over 3x plus b over 2x plus 1. So this is negative 10/3 over 2x plus 1. Now, I wouldn't really leave my answer like this. Like, this is technically the answer, but you can make that a little bit more appropriate, simplify it down some, and say that this is equal to 5 over 3x, subtract 10 over 3 times 2x plus 1. Yep. And this is what I would say is your answer. All right, partial fraction decomposition. Taking away or breaking a fraction up into its separate pieces. Just like if I had 3 plus 4 equals 7. What is 7? Well, 7 is 3 plus 4. If I had fractions, I'm breaking it up into the fractions, right? So we're taking this and breaking it up into the smaller pieces. That was a side example with no fractions, just to make sure you understand what it is we're doing. So let's do another one. First thing. Oh, let me make sure. Yep. First thing. Looking at it, the denominator, right? The denominator needs to be factored out. So I got, I guess we can just do this. 2 sets of parentheses. I know I got x and x, 2 numbers that multiply together to give you -3, but when you add them together, you get -2. That's going to be a -3 and a +1. So I know this fraction breaks up into being a over x minus 3 plus b over x plus 1. All right. So from here, we're multiplying everything by this least common denominator, right? The denominator we start with. When I do that, I'll be left with 5x minus 3 equals a times x plus 1 plus b times x minus 3. All right, this is kind of this is the one we're going to be working with. All right, from here, you decide if we want to solve. If I want to solve for A, right, then I'm trying to get rid of B. So I want to get rid of B. Well, what makes B be multiplied by 0? When we let x equal 3, because 3 minus 3 is 0. So when I want to solve for A, I get rid of the B. So 5 times 3 minus 3 is equal to A times 3 plus 1 plus B times, I don't know what I was doing there. Three minus 3, right? That goes to 0. I got 15 minus 3 is 12. 4a is equal to 12. I divide both sides by 4. And I got a equals 3. Solve for B. What makes A go away? Well, A goes away when x equals -1, right? So let x equal -1. When I do that, I got 5 times -1 minus 3 equals A times -1 plus 1 plus B times -1 minus 3. 5 times -1 minus 3 would be -8 equals -1 plus 1, 0. 0 times A, nothing. 0, right? B times -1 minus 3 is -4. Divide both sides by -4. And I got B equals 2. So now we got our answer. right? I can erase this A and B, and I can say A equals 3 and B equals 2. And this is our answer. All right. We'll do one more example. If you want to learn this, I suggest you pause the video, try to do it yourself. It's easy when you're just following whatever someone else is doing. When you start thinking about it on your own, that's where you figure out if you know something or not. So you might want to take a chance, some time to pause it. All right, so here we go. I know the factors it's already factored, so I got x plus 7 in the denominator plus 7x minus 1, and I know this is A and this is B. All right, broke it up. Next step, when we rewrite it, I'm going to be multiplying everything by the least common denominator, right? This denominator here, and that's going to give me 8x plus 7 equals A times 7x minus 1 plus B times x plus 7. All right, so this is kind of the one I'm going to be referring back to. And then if I want to solve for A, then I let x equal -7. All right, because I want to get rid of B. So this is 8 times -7 plus 7 equals A times 7 times -7 minus 1 plus B times -7 plus 7. That'll always cancel out because that's how we design it. 8 times -7 would be -56, right? Yep. Plus 7 would be -49 equals A times -7 times 7, -49, minus 1, which would be -50. So A would equal 49 over 50, right? Because we divided both sides by -50. Okay. On to the next. If we want to solve for B, we let x equal, now think about it. I got that 7x minus 1. If you set that equal to 0, then x would equal 1/7. Right? So we say 8 times 1/7 plus 7 equals A times 7 times 1/7, right? 7 times 1/7 would be 1, and then I minus 1, and that goes to 0, plus B times 1/7 plus 7. All right, so this is going to go to 0 because we designed it to be that way. 8 times 1/7 is 8/7 plus 7, which would be the same as 49/7. So that would be 49/7 plus 8/7, which would be 57 over 7, right? 57 sevenths equals B times 1/7 plus 7, which is the same thing as 1/7 plus 49 sevenths, which would be 50 sevenths. Well, first thing I'm going to do is multiply by 7 on both of these. 7's cancel out, and I got 57 equals 50B divided by 50. And I got B equals 57 over 50. All right. So we got A and we got B, so we can go back over here. I'm gonna erase this, A and B. And we're saying A is 49 over 50, and B is 57 over 50. But I really wouldn't want to leave my answer like that, just because you could simplify it further. So we're going to say this is 49 over 50 x plus 7 plus 57 over 57x minus 1. And that's it. So, practice. All right. Well, best of luck to you.